Hello guys, welcome on Tesla Adventures. In this video today, we are going to discuss the solutions of that practice mock test for gravitation. The syllabus of that mock test is capacitance and gravitation. So let us start from the question number 1. Now in this question you can see that there are two spheres whose radius is in the ratio of 1:2. Okay, and they both have a charge of Q which is 75 microcoulomb. They both have initially equal charge. They are now connected with a wire, and by connecting them with a wire they will be sharing the charges, and we very well know that Q total is 2Q and 2Q is 150, and the radius ratio R1 upon R2 is 1:2. So we have already done these kind of questions. What we need to do is the fact that we have to add up this ratio, which is by adding this ratio we would be getting 3, and we have to divide this total charge into 3 equal parts. So one part will be equal to 150 by 3, so it would be equal to 50. So we have to distribute this charge into the ratio in the ratio of radius. So if we know that radius ratio is 1:2, so we need to give one part to this one, 50 microcoulomb, and two parts to this one, that is 100 microcoulomb. So the amount of charge that is being transferred is 25 microcoulomb, because initially this smaller one was having a charge of 75 microcoulomb. Now it has a charge of 50 microcoulomb. So 25 microcoulomb has been transferred from a smaller one to bigger one. So the correct answer would be option A. Now we move on the next question. In this question you can see that we have to find out the charge on each capacitor in the steady state. Now you can see easily that if I redraw the diagram, then in the steady state the branches which have capacitors would not be having any current flowing through them. So there is no current through this branch, and therefore this 4 ohm will have no significance in the circuit. So this is 3 microfarad and this is 3 microfarad, and the current would be flowing from this middle 4 ohm. And similarly in the lower branch there would be no significance of that 4 ohm, and therefore this is 3, this is 3, and in the lowest branch there is a resistance 1 ohm, and this is 10 volt. Now you can just imagine that current would be flowing like that through this branch. Okay, so 4 and 1 would be in series, and therefore the current flowing through the circuit will be 10 by 5, which is 2 ampere, and a potential difference of 2 into 4, which is 8 volts, would be developed across this 4 ohm, and this 8 volt would be equally divided into all of 4 capacitors, 4 4 4 4. Okay, so the charge on any one of them, Q, will be equal to 3 into 4, which is 12 microcoulomb. So the correct answer would be D. Now let us move on the next question. Now you can see that in this question we have to find out the resultant capacitance between A and B. Okay, so what we can do in this question, you can see that these are not touching each other. So what we can do, we can open it up like that. See, this C and C are in series, so they would be C by, in fact, C by 2, and this is C. Okay, and this point is B, and this point is A, and there is this C, and another capacitor which is another branch which is connected between this point and this point. So it is again C and C are in series, so this is C by 2. So you can easily see that this is the situation. Now this is also point A and this is B. Now you can see that this is also B. So you can see that the terminal of one terminal of this capacitor is A and other is B. One terminal of this capacitor is A and other is B. One terminal of this capacitor is A and other is B. And one terminal of this capacitor is A and other is B. So these four capacitors are all in parallel, and we can just add up them. So C by 2, C by 2, C and C are equal to 3C. So the correct answer is C. Now we move on the next question. In this question you can see that we have to find out the equivalent capacitance between terminals X and Y. So you can see that this 100 and 100 are in parallel, so this is 200. Now 200 and 200 are in series, which is 100. Now again 100 and 100 will be in parallel, which would be 200. Now again 200 and 200 would be in series, which would be 100. And now again 100 and 100 would be in parallel, which is 200. So the correct answer would be 200. Now we move on the next question. In this question you can see that the magnitude of charge in steady state on either of the plates of the capacitor will be. Now we know that obviously in the steady state condition the current would be flowing through this branch only, and there would be no current flowing through capacitor branch. Therefore these resistances R2 and R will be in series, and hence we can find out the value of current. The value of current would be E upon total resistance, which is R2 plus R. And obviously this resistance would not have any significance in the circuit as there is no current flowing through it. So the potential difference developed across R2 will be equal to the potential difference developed across capacitor. So VC will be equal to IR2. So VC will be equal to ER2 upon R2 plus R. And therefore Q will be equal to CVC. So Q will be equal to CER2 upon R2 plus R. So the correct answer would be C. Now we move on the next question. In this question you can see that with what angular velocity Earth should spin in order that a body which is lying at 37-degree latitude may become weightless. Now what is 37-degree latitude is this point, and this angle is 37-degree. So we know that this is a formula, G dash is G minus R omega square cos square lambda, and we need to equate this G dash to 0 because the body has become weightless. So G is equal to R omega square cos square 37-degree, and G is equal to R omega square cos 37 is 4 by 5, so it would be 16 by 25. So omega will be equal to 25G upon 16R root, that is 5 by 4 under root G by R. So the correct answer would be option A. Now we move on the next question. In this question you can see that the parallel plates of a parallel plate capacitor are being moved away with the constant speed v. If the plate separation at any instant of time is d, then the rate of change of capacitance would be proportional to. This is a quite easy question. C we know is epsilon naught A by D and dC by dt. Okay, this is the rate of change of capacitance, would be epsilon naught A into minus 1 by d square into dd by dt. Now dd by dt is v because they are moving away with the rate v. So we can say that this is epsilon naught a v by d square with a negative sign. This negative sign indicates the fact that on increasing the separation between the plates of the capacitor, their capacitance would be decreasing. So obviously the correct answer will be B. Now we move on the next question. In this question, you can see that yeah. So in this question, you can see that at t is equal to 0, switch is closed, and for time t which is less than R into C1 plus C2, the current in the capacitor C1 in terms of the total current I would be. Now obviously we know that there is no resistance in these two branches. So what we can say that the potential of these capacitors would be same. Okay, and we know that V will be equal to Q1 by C1 and V is equal to Q2 by C2. And Q1 by C1 will be equal to Q2 by C2. So if we differentiate both the sides, we would be getting I1 by C1 will be equal to I2 by C2 and I1 by I2 will be equal to C1 by C2. And we know that I is equal to I1 plus I2. So if we divide these two currents in this ratio, so the current flowing through the C1, which is I1, would be equal to C1I upon C1 plus C2. So the correct answer would be C. Now we move on the next question. In this question, you can see yes, you can see that the work done against electric forces in increasing the potential difference of a capacitor from 20 to 40 volt is W. Now work done in increasing the potential difference from 40 to 50 volt would be. So obviously the work done will be equal to delta U, considering that there is no resistance in the circuit. So work done is delta U, and delta U is half C, and initially we have increased the voltage from 20 volt to 40 volt. So this is 40 square is 1600 and 20 square is 400. So W is equal to, this is 600 C. Okay. Now in the second case, let us suppose that work done is W dash. So it would be half C into 2500 minus 1600, and W dash will be half C into, this is 900, and W dash will be equal to C into 450. So if we divide these two, W dash upon W, then it would be equal to 3 by 4. So W dash will be equal to 3W by 4. So the correct answer would be B. Now we move on the next question. Now in this question, you can see that there are two spherical conductors A1 and A2, and these are having a radius of R1 and R2. These are placed concentrically in air, which means that their center is same, and these two are connected with a copper wire as shown. Their equivalent capacitance would be we know that when we connect these concentric spheres, all of the charge which is residing on the inner sphere would be appearing on the outermost surface of the outer sphere. And if outermost surface, all the charge would be on the outermost surface of the outer sphere like that, then there would be only one capacitor, which is the isolated capacitor of radius R2. So the capacitance would be 4 pi epsilon naught R2. So the correct answer would be option C. Now we move on the next question. In this question, you can see that we have to choose the correct graph between potential and time for an isolated conductor of finite capacitance C if the charge appearing on it is varying according to the formula Q is equal to alpha T plus Q naught. Okay, so this is a simple one. You can see that Q is equal to CV and V will be equal to Q by C. So Q is alpha T plus Q naught and divided by C. So this is a straight line obviously. So the correct answer would be A. Now we move on the next question. In this question, you can see that there are two conducting spheres. These are two conducting spheres of radius A and B, and they carry equal and opposite charge. Now they are placed at a separation D which is very greater than A as well as it is greater than B. Now the capacitance of this system would be, now let us suppose that it has a charge of Q and it has a charge of minus Q. Now I have seen that many of the students are confused about the fact that whether they will influence each other or not, because it is given that D is very greater than A or B. So what we should look in the options, that in each and every term there is D. So we have to consider the influence of this on this and influence of this on this. Okay, so let us see that the potential V1 of the first sphere, this one, would be KQ by A minus KQ by D. This is the potential due to this one. And the potential V2 of the bigger sphere, this one, would be KQ by D minus KQ by B. Okay, now we know that we have to find out delta V, which is V. So this is V1 minus V2. So V1 minus V2 would be KQ is common, and this is 1 by A minus 1 by D minus 1 by D plus 1 by B. So this is Q upon 4 pi epsilon naught 1 by A plus 1 by B minus 2 by D. So I think we can easily guess the answer. So answer is D. Now what further we have to do? We have to compare it with Q is equal to CV and V is equal to Q by C. So answer is predictable and answer would be D. Now we move on the next question. In this question you can see that this circuit is shown and all the capacitors were initially uncharged. Now the current flowing through the resistor PQ just after closing the switch would be. So let us draw the scenario just after closing the switch. So we know that as soon as we would close the switch, all the capacitors would be short circuited, and this would be the scenario. Like that. This is 6, this is 5, and this is 6. Okay, so we have to find out the current flowing through this one. So you can see that obviously if we see that these three are in parallel, and if you draw this connection, then it would be something like that. This is 1 ohm and this is 12 volt. So it would be like that. So this is the equivalent resistance of these three. So this is open circuit and no current will flow, or we can say that the current will flow like that. It would not go in this branch. Okay, it would follow the path which has least resistance. So the current flowing through these three resistances would be 0. So the correct answer is D. Now in this question, you can see that n resistances are connected like that and capacitors are connected like that. Each of them are in parallel to each other, and they are also connected in parallel with a battery whose EMF is E. Now in the steady state condition, we have to find out the ratio of the charge stored in the first and the last capacitor. Obviously, all of the branches would be having a same potential difference of E because they all are connected in parallel. So a same potential difference of E would be developed across this R, this C, this R, this C, and all of them. So we can easily predict that if all the capacitors are equal and potential difference across them is equal, so the charge stored in them would be also equal, and therefore the ratio of charge stored in them would be 1:1. Now let's move on the next question. In this question you can see that there are 6 capacitors, each having a capacitance of C, and they are connected as shown. Initially all of them was uncharged, and now a battery of EMF E is connected. Now we have to find out that how much charge will flow through the battery if this switch is on, if we switch on this key. So obviously this is a very easy question. We can redraw the circuit. We can see that if this point is A, this is A, this is A, this is A, and if this point is B, this is B. So you can see that this has a terminal of A and B, this has a terminals of A and B, and this has a terminals of A and B. So they all are in parallel, and you can also see that their parallel combination would be like that it would be 3C, and this is B and this is A, and another capacitor A, let's suppose it is D. So another capacitor A, this one is connected between A and D. So this is A and D, this is D, and there are 2 capacitors connected in parallel between B and D, so that would be 2C. So this is C, so you can see that 3C and 2C are in series, so the equivalent capacitance of these two would be 6C by 5, and 6C by 5 and C are in parallel to each other, so it would be 11C by 5. So the charge flowing through the battery, this is C equivalent is 11C by 5. So the charge flowing through the battery would be option B, which is 11CE by 5. Now let's move on the next question. In this question you can see that this circuit AB is shown in the figure, and EMF of the source, this source is 10 volts. The capacitance of the capacitors are equal to 1 and 2 microfarads, and the potential difference between A and B is 5 volts. The voltage across these capacitors would be, so let us first of all find out the charge flowing through this. So we know that these are in series, so the charge flowing through them would be same, and let us apply the KVL in the open loop. So VA minus Q by C1 minus E minus Q by C2 is equal to VB. So VA minus VB minus E is equal to Q 1 by C1 plus 1 by C2. Okay, and obviously VA minus VB is given as 5, so this is 5, and it is given as 10, so it is 10, and Q by C1 is the potential difference across this one, and Q by C2 is the potential difference across this ones, and C1 is 1, C2 is 1 by 2. So let us find out Q. So this is 1 plus 1 by 2, and this is minus 5, and this is 2 divided by 3. So Q will be equal to minus 10 by 3. So Q is minus 10 by 3, and the potential difference across C1 is V1. So V1 will be equal to 10, in fact it would be Q by C1. So it is 10 by 3, and V2 will be equal to Q by C2, which is 5 by 3. So the correct answer is A. And you can see that there is no problem of sign in all of the 4 options, so we can just ignore this negative sign. This negative sign is indicating the fact that the potential difference, the charge is not flowing like that. In fact, the charge is flowing in the reverse direction, which as we have assumed. So now let's move on the next question. In this question, you can see that there is a parallel plate capacitor of capacity C, and it is connected to a battery and is charged to a potential V. Another capacitor of capacity 2C is connected to another battery and it is charged to a potential of 2V. Now the charging batteries are removed, and now these condensers are connected in such a way such that the positive polarity of one is connected to the negative plate of the second one. So the final energy of the system would be, now we know obviously that V common would be C1 V1 minus C2 V2 upon C1 plus C2. This minus is due to the fact that the positive polarity of one is connected to the negative polarity of the other. So V common would be equal to C into V. In fact, let us take bigger one before the smaller one. So it would be 4CV minus CV divided by 3C. So V common will be equal to V, you can see, and U final will be half C V square plus half 2C V square. So this is 3 by 2 CV square. So the correct answer would be C. Now we move on the next question. In this question you can see that we have to find out the charge on these two capacitors, and the battery is connected across these 2 points, and the resistance of other branches is R. Okay, now you can easily, we have already solved the cube questions of equivalent capacitance and resistance, and we can see that if we if we join this line, and if we place a mirror, or if we place a mirror like that, this is the mirror. So you can see that circuit is symmetric. Mirror image of this is this, mirror image of this is this, mirror image of this is this, and mirror image of this is this. Mirror would be placed like that also. So you can see that the current flowing through this resistance, this one, would be flowing through this one, and the current flowing through this resistance would be flowing through this one, because we have used perpendicular symmetry. So in perpendicular symmetry we know that the current flowing through object resistance is equal to the current flowing through the image resistance. So if the current flowing through this is same as current flowing through this, and current flowing through this is same as current flowing through this, and current flowing through this is same as current flowing through this, and current flowing through this is same as current flowing through this. So we can predict that there would be no current or no charge flowing through this branch, capacitor branch, and similarly for that. So the charge stored in the capacitors would be obviously 0 due to symmetry. Now we move on the next question. In this question you can see that there are 2 planets A and B which travel counterclockwise in the circular orbits around a fixed star. Now counterclockwise is obviously anticlockwise. The radius of their orbits are in a ratio of 1:4, and at some time they are aligned to each other so that these are in straight line, and at certain time planet A comes back to the initial position, completing one full circle about the star. In the same time, the angular displacement of the second planet would be. Now this is, I think, a very easy question. You can see that we know that the ratio of time period t1 by t2, or we can just square them. So t square is proportional to r cube, we know. So the ratio of their time periods would be 1 upon 4 cube. 4 cube would be equal to 64. So t1 by t2 will be equal to 1 upon 8, and hence omega 2 by omega 1 will be equal to 1 upon 8, because the ratio of time period is inverse of ratio of omega. Okay, so the time in which one of them has completed a full circle is and the angle it covers would be 360, and 360 divided by 8 would be equal to 45 degrees. So the other planet would cover an angle of 45 degrees. So the correct answer is D. Now we move on the next question. In this question, you can see that the plate separation in a parallel plate capacitor is D, and the plate area is A. If it is charged to a potential V and battery is disconnected, then the work done in increasing the plate separation to 2D would be. Now we know that if plate separation initially was D and plate area was A, so Q stored initially would be epsilon naught A by D into V. And now we have removed the battery, so Q would become constant. So work done would be now equal to change in energy of the capacitor. So U final minus U initial. So U final would be half Q square by C final, and U initial would be half Q square by C initial. And Q square we have already discussed that it would be remaining constant. So this is epsilon naught square A square V square by D square. And C final is the capacitance when the separation was 2D. So this is 2D by epsilon naught A, and this is D by epsilon naught A. So work done would be equal to half epsilon naught square. In fact, let us cancel out this. So this is epsilon naught A V square divided by D. So the correct answer would be equal to option D. Now we move on the next question. In this question, we have to find out the charge on this capacitor in steady state. Now we can see easily that in steady state the current flowing through this circuit would be like that this would be I and this would be going, and it would be divided into two parts, I by 2, and then I would be like that. So you can see that this 20 and 20 which are in parallel to each other is 10, and 10 and 10 are in series. So the equivalent resistance would be equal to 20, and the current I would be 2 by R equivalent. So I is equal to 1 by 10. So the voltage developed across this 10 ohm resistance is the same voltage that is developed across this capacitor, and the capacitor Q, the charge on the capacitor will be equal to CV, and CV and V will be equal to I into 10, and this is 1, so Q will be equal to 6 into 1, which is 6. So the correct answer is 6. Now we move on the next question. In this question you can see that we have to find out the equivalent capacitance of this infinite ladder. And we already have done these kind of questions. So what we have to observe is the fact that this 6 and 8, these branches are going to infinity, and if we are coming from the last branch towards A and B, and we just have left out this one branch, this one, this one we have left out. So till this point, if the equivalent resistance is X, so till this point it would also be X, and therefore what we can draw is this is 6 and this is 8, and this point is C and this point is D. Now C and D are these points, C and D. And this is X. Okay, so the equivalent between C and D would also be X. So we can calculate this, and you can see that 8 and X are in parallel and they are in series with 6. So equivalent capacitance would be 6 into X plus 8 upon 6 plus X plus 8, which is 14 plus X, and that is equal to X again. So 6X plus 48 is equal to 14X plus X square. So X square plus 8X minus 48 is equal to 0. And you can see that X square plus 12X minus this is 4X minus 48 is equal to 0. So this is X, this is 1X plus 12, and minus 4 is also common. This is X plus 12. So X could not be negative because capacitance cannot be negative, so X is equal to 4. So the capacitance till this point is 4, and if we draw further, then this is A and this is B, and this branch has a capacitance of 8 and capacitance till this point is 4. So the equivalent capacitance between A and B is 12. Now we move on the next question. In this question you can see that we have to, this is 1 microfarad capacitor and this is resistance, and this is cell of EMF 3 volts, and the value of that internal resistance of the cell is also 0.5, and the value of resistances is 4 and 1, and we have to find out the charge on the capacitor in steady state. Now obviously we know that in a steady state there is no current flowing through this resistance, therefore we can remove this resistance and current would be flowing like that. Okay, so I will be equal to V by R. Now R is 1 and 0.5, so this is 3 by 2. 1 plus 0.5 is 1.5, so I is equal to 2 ampere, and the voltage across this resistance V will be the same as the voltage across capacitor. So you can see that Q is equal to CV and V is equal to I R2. Now R2 is 1, so V is equal to 2 and Q is equal to 1 into 2. So the correct answer is 2. Now we move on the next question. In this question you can see that there are two stars in a certain binary star system which move in the circular orbits. The first star alpha moves in an orbit of radius this, and the other star moves in an orbit of radius this. Okay, so what is the ratio of their masses of star B to star A? So in you know that in a binary star system these stars move around their center of mass, and obviously when they are moving around the center of mass, then m1 r1 will be equal to m2 r2, where r1 and r2 are their distances from the center of mass, or we can say that r1 and r2 are the orbit radius. Okay, and we have to find out the ratio of m beta upon m alpha. So m2 by m1 we have to find out, and that would be equal to r1 by r2, and r1 is 10 to the power 9 and r2 is 5 into 10 to the power 8. So you can see then it is 2. So the correct answer is 2. Now let's move on the next question. In this question we have to calculate the steady state current in 2 ohm resistance, this one, and the internal resistance of this cell is negligible and capacitor is 2.2 microfarad. So in steady state we again know that there would be no current flowing through this one. So the total resistance, equivalent resistance of these two would be 6 upon 5, which is 1.2, and the total R equivalent would be 2.8 plus 1.2, which is 4, and the current I will be equal to V by R equivalent, which is 60 by 4, that is 15, and the current which is flowing through this would be 15. And now we have to find out the current through 2 ohm. So this is I1, let's suppose, and we know that the ratio of these resistances is 2:3, which is 5. We have to sum these ratio, so R1 plus R2 is 5, and we have to divide this 15 into 5 equal parts, so one part would be 3, and from this resistance the current flowing would be decided by the neighboring one, so there would be 3 parts flowing through it, so 3 parts would be 9. So the correct answer is 9. So I1 is 9. Okay, now let's move on the next question. In this question you can see that there is a binary star that consists of 2 stars A and B of the masses shown, and the mass ms is the mass of sun. They are separated by a distance of d and they are rotating about their center of mass, which is stationary. So the ratio of total angular momentum of the binary star to the angular momentum of star B about the center of mass. Now we know that let us draw the scenario. First of all, let us see that if mass of star MA is let's suppose, yeah, this is M, so then the mass of star B is 5M. You can see that 2.2 into 5 is 11, and we have to find out the ratio of total angular momentum of this binary star to the angular momentum of the star B. So the total angular momentum is LA plus LB upon the angular momentum of LB. So let us suppose that this is X. So X is 1 plus LA by LB. Okay, and X will be equal to 1 plus. Now you can see that if you remember that their omega was same. So LA, angular momentum, is I omega, so omega is same, so this is IA by IB. You know that in binary star omega is same, and their IA and IB, the ratio of their IA and IB we have to find out. So this is M and this is 5M, and obviously this center of mass COM can be this is D, so the ratio of these two is 1:5. So if we add up the ratio, it is 6, and if we divide D into 6 equal parts, then one part would be D, and the ratio of center of mass, in fact this distance X can be directly calculated. it would be 5d by 6, and this remaining distance would be d by 6. Okay, so this is the center of mass. So x would be equal to 1 plus m a, which is m. M a is m, and the distance of m a from the center of mass is 5d by 6. So this is 5d by 6 whole square divided by 5m into d by 6 whole square. So cancelling m with m, so it would be equal to, let us use another page. So x will be equal to 1 plus, this is 25 by 36, and there would be a 36 term also in denominator, so it would be cancelled out. So this is 5, so this is 5, so it is x is 6. So the correct answer is 6. Now we move on the next question. In this question, you can see that assuming that Earth to be a sphere of uniform mass density, the energy needed to completely disassemble the planet against the gravitational pull among its constituent particles is this one. Find out the value of x. And it is given that the product of mass and the radius of Earth is this one. Okay, and g is this. So we know that this is self energy. So the energy needed to disassemble the Earth is its self energy. And self energy of solid sphere is 3 by 5 gm square by r. Okay, so this is the, with a negative sign, so this is the self energy. So U self would be, now we have to give this energy, so the energy given would be positive, so let us use plus sign. So this would be 3 by 5 g m square by r. Now let us, what we should do, that product of mass of Earth and radius of Earth is this one. So what we should do, that we should multiply and divide with r, and in fact m into r is 5 by 2 into 10 raised to power 31. So m will be equal to 5 by 2 into 10 raised to power 31 by r. So let us substitute this value of m. So this is 3 by 5 into g into 25 by 4 into 10 to the power 62 divided by r cubed. Okay, and r we know is 64 into 10 raised to r is 6400 kilometer. So r is 64 into 10 raised to power 5 meters. So you can see that if we substitute these values, the answer would be equal to 15. So the correct answer would be 15. I am not solving, it is not required to solve. You can easily check the answer. Now let's move on the next question. In this question, you can see that the gravitational acceleration on the surface of a planet is under root 6 by 11g, where g is the gravitational acceleration on the surface of Earth. The average mass density of that planet is 2 by 3 times of that of Earth, and if the escape speed on the surface of the Earth is taken to be 11 km per hour, then the escape speed on that planet would be. Now we know that escape speed is under root of 2gm by r. Okay, and we can also write it, in fact, we can also write it as under root 2gr. Okay, so this is the escape velocity formula. So V escape on that planet upon V escape on Earth would be equal to under root of g of that planet into r of that planet upon g of Earth into r of Earth. Okay, and what we can do, that Yeah, what we can do that G, we can write down G as Gm by, now let us first of all, Vp by Ve will be equal to under root of Gp by Ge is root of 6 by 11, and we have to find out Rp by Re. So we know that G dash is under root of 6 by 11 G, and G dash is G m dash by R planet square, and that is equal to root of 6 by 11 G m of earth by R of earth square. I'm cancelling G with G. Now let us use another page. So m dash upon R planet whole square is equal to under root of 6 by 11 into m by R earth whole square. Now m can be written as density into volume. So you can see that 4 by 3 pi Rp into density of that planet rho p, and this is root 6 upon 11 into 4 by 3 pi Re into density of earth, cancelling 4 by 3 with 4 by 3. So we have to find out Rp by Re. So Rp by Re will be equal to root of 6 by 11 into rho E by rho P, and the average mass density of planet is 2 by 3 times of that of earth. So rho of planet upon rho of earth is 2 by 3. So rho of earth upon rho of planet is 3 by 2 into root of 6 by 11. So we have to substitute this value Vp by Ve. So Vp by Ve is equal to under root of 6 by 11 root 6 by 11 into Rp by Re. So into Rp by Re is 3 by 2 into under root of 6 by 11. Okay, so you can see that this is 3 by 11. Root 6 is 6, 6 by 2 is 3, 3 into 3 is 9, and 11 into 11 is 121. So root of that is 3 by 11. So escape velocity of earth is 11, so V is escape on that planet would be 3. So the correct answer is 3. Now we move on the next question. Okay, now in this question you can see that there is a ring of radius 8 that is made up of highly dense material, and the mass of ring is this. This mass is distributed uniformly over the circumference of the ring, and there is a particle of mass this one is placed on the axis of the ring at a distance of 6 meters from the center. So we have to neglect all other forces except the gravitational interaction, and we have to determine the speed of the particle at the instant when it would pass through the center of the ring. So this is the case in which, let us draw the scenario that this is the ring, and mass of the ring is, let's suppose, m1, and mass of the particle is small m, and this distance is x, which is equal to 6 x naught. So we have to find out the velocity of this particle when it would pass through this point. Now what we have to do, that let us suppose that this point is O and this is O dash. So the potential of O dash will be equal to Gm by under root of x naught square plus r square with a negative sign, and potential of O will be equal to minus Gm by r. Okay, and we know that m delta v will be equal to half mv square. V is the velocity, so velocity will be equal to 2 into delta v root. We have already calculated the delta V. You can substitute the values and answer would be 9. Now let's move on the next question. In this question, you can see that there is a solid sphere of radius r and density rho, and there is a spherical cavity of radius r by 4 that is carved in the sphere as shown. A particle of mass m is released from rest from this point B, and we have to find out the velocity of the particle at the instant when it would strike the cavity. Okay, so we know that the gravitational field intensity inside the cavity would be towards this side, and I would be equal to, by analogy of electrostatics, we know that electric field inside the cavity was rho into distance between the centers upon 3 epsilon naught, where g is equal to 1 upon 4 pi epsilon naught. So epsilon naught can be replaced by g. So the distance between the centers is r by 2, so I would be equal to rho r by 2 into 3 divided by epsilon naught. Epsilon naught is 1 upon 4 pi g, so this is 4 pi g. So I would be equal to 2 pi g rho r by 3. This is I. And we have released this mass from this point, and we have to find out the velocity of this mass when it would strike point A. So the force acting on this mass would be ma, and the acceleration would be F by m. So acceleration of this mass would be same, I. So it would be 2 by 3 pi g rho r. So let us calculate the value of this. So this is 2 by 3 pi, and g is 20 by 3 into 10 raised to power minus 11, and rho is 10 by pi into 10 raised to power 3, and r is 3. So you can see that cancelling pi with pi, 3 with 3, and it is A will be equal to this is 44 into this is 10 to the power minus 8 and 10 to the power minus 7. Okay, and this is 10 to the power minus 6. So this is 4 by 3 into 10 to the power minus 6. And we have to find out its velocity. So V, let us use another page. So V is equal to under root 2AS. So V will be equal to under root of 2 into A, which is 4 by 3 into 10 raised to the power minus 6, 4 by 3 into 10 raised to the power minus 6. And distance is this one, so this is r by 2. Okay, and r is 3 meter, so this is r by 2, so r is 3 meters. So you can see that cancelling this with this, V will be equal to 2 into 10 raised to the power minus 3. And what we have to do, we have to find out the velocity in millimeter per second, so obviously it would be 2. So the correct answer is 2. Okay, so I would be showing you the answer key of these questions, this paper at the end, and I would be uploading the JEE Advanced mock test based on capacitance soon. Thank you.